long before humans built telescopes, people looked up at the night sky and noticed a strange red star glowing in the shoulder of the constellation Orion. It was brighter than most stars, but something about it felt different. Its color was deep red. Its brightness slowly changed over time. For centuries, no one understood what this mysterious star truly was. Today, we know that Betelgeuse is not just another star in the sky. It is a dying red supergiant, hundreds of times larger than our Sun. If it replaced the Sun, its enormous atmosphere would stretch beyond the orbit of Mars, swallowing the inner planets of our solar system. And one day, in the distant future, Betelgeuse may explode in one of the most spectacular cosmic events the universe can produce. A supernova so bright it could briefly shine in Earth's daytime sky. Tonight, on Stellar Depth, we explore the mystery of Betelgeuse, the giant red star that reminds us just how powerful and unpredictable the universe can be. And if you enjoy exploring the deep mysteries of space, don't forget to subscribe to Stellar Depth, because the universe still holds countless secrets waiting to be discovered. The red star in Orion. On a clear winter night, when the sky is dark and the air is calm, one constellation stands out more than almost any other. It is the mighty hunter known as Orion. Even without a telescope, Orion is easy to recognize. 3 bright stars form a straight line across the sky. Orion's famous belt. Above that belt shines a reddish star, glowing softly against the darkness. That star is Betelgeuse. For thousands of years, people have looked at Betelgeuse without knowing what it truly was. Ancient civilizations saw it as part of the hunter's shoulder. Its deep orange-red glow made it appear different from other stars, and many cultures associated it with fire, strength, or danger. But long before modern astronomy, no one understood the true nature of this strange star. Today, we know that Betelgeuse is not just another star in the sky. It is one of the most extraordinary objects in our cosmic neighborhood. Betelgeuse lies about 640 light-years away from Earth. In cosmic terms, that distance is relatively close. Many stars we observe are thousands or even millions of light-years away. Yet despite its distance, Betelgeuse shines as one of the brightest stars visible from Earth. The reason is simple. Betelgeuse is enormous. To understand just how large it is, we must first think about our own star, the Sun. The Sun may appear huge to us, but compared to the largest stars in the universe, it is actually quite modest. Betelgeuse belongs to a class of stars known as red supergiants, stars that have expanded to truly incredible sizes near the end of their lives. Betelgeuse's radius is estimated to be roughly 700 to 1,000 times larger than the Sun's radius. If Betelgeuse replaced the Sun at the center of our solar system, its outer atmosphere would stretch beyond the orbit of Mars. In some estimates, it could even approach the orbit of Jupiter. Every planet in the inner solar system, Mercury, Venus, Earth, and Mars, would disappear inside the star's massive atmosphere. This comparison reveals something astonishing. Even though Betelgeuse is only one star among billions in the Milky Way, it is already far larger than anything within our own solar system. But size is not the only thing that makes Betelgeuse special. The star is also unstable. Unlike the Sun, which shines steadily for billions of years, Betelgeuse behaves more like a cosmic storm. Its brightness changes over time. Sometimes it shines brighter. Other times it fades slightly. Astronomers classify Betelgeuse as a variable star, meaning its brightness fluctuates as its enormous atmosphere expands and contracts. These changes can occur over months or years, and sometimes they become dramatic. In late 2019, astronomers around the world noticed something strange. Betelgeuse began to dim rapidly. Within a few months, its brightness dropped so much that it became noticeably fainter in the sky. This event quickly became known as the Great Dimming. For a moment, scientists wondered whether the star might be preparing to explode, because Betelgeuse is a dying star. One day, it will end its life in a supernova explosion, one of the most powerful events in the universe. But the Great Dimming turned out to have a different explanation. Observations later revealed that Betelgeuse had ejected a massive cloud of gas into space. That gas cooled and formed dust, which temporarily blocked some of the star's light from reaching Earth. In other words, the star had essentially created its own cosmic dust cloud. Yet, even though that event did not signal an immediate explosion, it reminded astronomers of something important. Betelgeuse is living on borrowed time. Compared to stars like the Sun, which may live for billions more years, Betelgeuse could explode relatively soon. In astronomical terms, that might mean within the next 100,000 years. That may sound like a long time to us, but on cosmic timescales it is extremely short. The star is approaching the final stages of its life. Inside its core, nuclear reactions are slowly running out of fuel. Gravity continues pulling inward, while radiation pushes outward. This delicate balance cannot last forever. Eventually, the core will collapse, and when that happens, Betelgeuse will explode in a brilliant supernova. For a brief time, the star could shine as brightly as the moon in Earth's sky. But that dramatic future lies ahead. For now, Betelgeuse continues to glow quietly in the shoulder of Orion, a massive red star slowly pulsing and changing, a giant that has fascinated humanity for thousands of years, and a star that reminds us just how strange and powerful the universe truly is. A giant on the edge of death, the star Betelgeuse may look calm from Earth, a steady red glow resting in the shoulder of Orion. But beneath that peaceful appearance, Betelgeuse is one of the most violent and unstable stars in our cosmic neighborhood. Unlike the Sun, which is still in the stable middle of its life, Betelgeuse has already entered the final stage of stellar evolution. It is what astronomers call a red supergiant. That means this star has already consumed most of the hydrogen fuel that once powered its core. And when that fuel ran out, something dramatic happened. Gravity began crushing the core inward. As the core collapsed, temperatures inside the star rose dramatically. That heat triggered a new stage of nuclear fusion. Helium atoms began fusing into heavier elements like carbon and oxygen. But while the core was shrinking, the outer layers of the star reacted in the opposite way. They expanded, and they expanded enormously. The star ballooned outward until it became hundreds of times larger than before. This transformation turned Betelgeuse into one of the largest stars visible from Earth. Its diameter is so immense that if it replaced the Sun, its outer atmosphere would swallow the orbits of several planets. Even the orbit of Mars would lie deep inside the star's massive envelope. But the most fascinating part of Betelgeuse is not just its size. It is the chaos occurring inside its atmosphere. Stars like the Sun have relatively stable surfaces, but the surface of Betelgeuse is constantly changing. The star's enormous size allows gigantic convection cells to form. These are rising and sinking currents of hot gas that transport energy from the interior toward the surface. On Earth, convection happens in boiling water. Small bubbles rise to the surface and burst. But on Betelgeuse, convection works on a scale that is almost impossible to imagine. Each convection cell can be larger than the entire orbit of Earth. These giant bubbles slowly rise through the star's atmosphere, cool as they reach the surface, and then sink again. As they move, they reshape the star's surface. Some regions glow brighter, others grow darker. This constant motion is one of the reasons Betelgeuse changes brightness over time. But convection is not the only force affecting the star. Betelgeuse is also losing mass at an incredible rate. Powerful stellar winds constantly blow gas away from the star's outer layers. These winds carry huge amounts of material into space. Over thousands of years, Betelgeuse has already shed massive clouds of gas and dust into the surrounding region of the Milky Way. Astronomers have observed enormous arcs and shells of gas drifting away from the star. These structures are evidence of the star's unstable atmosphere. Some eruptions are so powerful that they eject material millions of kilometers into space. Once this gas cools, it can form cosmic dust. That dust then drifts through interstellar space. Eventually, it may become part of future stars and planets. In this way, Betelgeuse is already contributing material to the next generation of the galaxy. Yet the instability of the star does not stop there, because Betelgeuse is also pulsating. Its outer layers slowly expand and contract in cycles. These pulsations can occur over months or even years. When the star expands, its surface cools slightly and the star dims. When it contracts, it becomes hotter and brighter again. These cycles are part of the reason Betelgeuse has fascinated astronomers for centuries. But occasionally, something even more dramatic occurs. As mentioned earlier, the star experienced a mysterious dimming event in 2019. During that time, Betelgeuse suddenly became much fainter than usual. For a moment, astronomers wondered whether the star might be on the verge of exploding. Telescopes across the world began observing the star. Space observatories collected detailed measurements. Eventually, scientists discovered the cause. Betelgeuse had expelled a huge cloud of gas from its surface. That gas cooled and condensed into dust. The dust temporarily blocked some of the star's light from reaching Earth. In other words, the star had briefly hidden itself behind its own debris. Although the event was dramatic, it did not signal the immediate death of the star. Instead, it revealed just how unstable red supergiants can be. Betelgeuse is constantly changing. Its enormous atmosphere behaves more like a stormy ocean than a solid surface. Massive plumes of gas rise and fall. Winds push material into space. And convection currents reshape the star again and again. Yet all of this activity is only a prelude to something much larger. Because deep inside the core of Betelgeuse, nuclear reactions continue producing heavier elements: carbon, neon, oxygen, silicon. Each stage burns faster than the one before. and eventually the core will begin producing iron. That moment marks the beginning of the end for a massive star. Because iron cannot release energy through fusion, once iron accumulates in the core, the star can no longer support itself against gravity. When that happens, the core will collapse, and the star will explode. But that dramatic moment still lies somewhere in the future. For now, Betelgeuse continues shining as one of the most remarkable stars visible in our sky, a gigantic red supergiant, unstable, changing, slowly drifting toward its final fate, and reminding us that even the brightest stars are only temporary lights in the vast darkness of space. The surface of a giant star. When astronomers observe Betelgeuse, they are not looking at a calm star like the Sun. Instead, they are observing something far more chaotic. The surface of Betelgeuse behaves less like a solid sphere, and more like a massive ocean of boiling plasma. From Earth, the star appears as a single point of reddish light in the constellation Orion. But when astronomers examine it with powerful telescopes, they discover a very different reality. Betelgeuse is not smooth. Its atmosphere is turbulent, uneven, and constantly changing. Gigantic plumes of hot gas rise through the star's outer layers. Meanwhile, cooler gas sinks downward again. This motion is driven by convection, the same physical process that occurs when water boils on a stove. But on Betelgeuse, convection happens on a scale almost impossible to imagine. Because of the star's enormous size, its convection cells are incredibly large. Some of these cells may be comparable to the entire orbit of Earth around the Sun. Imagine a bubble of hot gas the size of Earth's orbit slowly rising across the surface of a star. That is the scale of activity happening on Betelgeuse. These giant convection cells cause the star's brightness to fluctuate. Some regions glow brighter as hot gas rises to the surface. Other regions appear darker as cooler gas sinks back down. The entire surface constantly shifts and reshapes itself over time. Astronomers have even managed to capture images of these patterns. Using advanced instruments such as the Very Large Telescope, scientists have observed enormous, bright patches on the star's surface. These patches reveal where giant plumes of hot gas are rising from deep inside the star. Unlike smaller stars, which may have thousands of small convection cells, Betelgeuse may have only a few enormous ones. Each of these massive cells can dominate a large portion of the star's surface, and because they evolve slowly, the appearance of the star changes over months or years. But convection is only one part of Betelgeuse's strange behavior. Another factor shaping the star is its extremely thin atmosphere. Even though the star is enormous, its outer layers are surprisingly diffuse. If Earth somehow orbited inside Betelgeuse's atmosphere, the surrounding gas might actually be less dense than the air near the edge of Earth's atmosphere. This means the star's surface is not a sharp boundary. Instead, it gradually fades into surrounding space. Gas drifts outward from the star in powerful stellar winds. Over time, these winds carry huge amounts of material away from the star. Betelgeuse is constantly shedding mass into the surrounding region of the Milky Way. Astronomers have observed enormous clouds of gas surrounding the star. Some of these structures extend for trillions of kilometers. They form glowing arcs and shells around Betelgeuse, created by past eruptions from the star's surface. These eruptions occur because the outer layers of the star are only loosely held together by gravity. The star's immense size weakens its gravitational grip on its own atmosphere. As a result, even relatively small disturbances inside the star can push gas into space. Sometimes, entire chunks of the atmosphere are ejected outward. Once that gas cools, it condenses into cosmic dust. That dust then drifts slowly through interstellar space. Over millions of years, it may become part of new stars and planets forming elsewhere in the galaxy. But the star's surface activity does not stop with convection and stellar winds. Betelgeuse also experiences massive stellar eruptions. These eruptions can release huge plumes of gas far into space. In fact, astronomers believe that some of the giant gas clouds surrounding Betelgeuse were created by such eruptions. One particularly dramatic event occurred shortly before the Great Dimming, in 2019. Observations suggest that a massive plume of gas erupted from the star's surface. That gas later cooled and formed dust. When the dust drifted between Betelgeuse and Earth, it partially blocked the star's light. This caused the star's brightness to drop dramatically for several months. Although the star eventually returned to normal brightness, the event revealed something important. Betelgeuse is extremely active. Its atmosphere behaves more like a stormy ocean than a stable surface. Huge waves of plasma rise and fall. Giant bubbles of gas move slowly across the star, and enormous plumes of material are occasionally thrown into space. Yet despite all this activity, Betelgeuse remains relatively cool compared to many other stars. Its surface temperature is around 3,500 Kelvin, much cooler than the Sun's surface temperature of about 5,800 Kelvin. This cooler temperature is what gives Betelgeuse its deep reddish color. But even though it is cooler, the star is still incredibly luminous. Because it is so enormous, its total surface area is immense. This allows the star to radiate vast amounts of energy into space. In fact, Betelgeuse shines tens of thousands of times brighter than the Sun. And all of this energy is produced deep inside the star's core, where nuclear fusion continues shaping the star's destiny. Yet, the instability we observe on the surface tells us something important about the star's future. Betelgeuse is not stable. Its enormous size, powerful convection currents, and continuous mass loss all indicate that the star is approaching the final stages of its life. Deep inside its core, nuclear reactions are gradually changing the star's internal structure. And when those reactions finally reach their limit, the surface chaos we see today will lead to something far more dramatic: the death of a giant star, a cosmic explosion that will briefly transform Betelgeuse from a quiet red light in the sky into one of the brightest objects the night sky has ever seen. What if Betelgeuse replaced the Sun? To understand the true scale of Betelgeuse, astronomers often imagine a dramatic scenario. What if this enormous star suddenly replaced the Sun at the center of our solar system? The answer reveals just how extreme Betelgeuse really is. The Sun may seem huge from Earth. Its diameter is about 1.39 million kilometers, large enough to fit more than 1 million Earths inside it. But compared to Betelgeuse, the Sun is actually quite small. Betelgeuse's radius is estimated to be between 700 and 1,000 times larger than the Sun's radius. That means its diameter stretches billions of kilometers across space. If this red supergiant replaced the Sun, the entire structure of our solar system would be swallowed. The first planet to disappear would be Mercury. Mercury orbits the Sun at a distance of about 58 million kilometers. But inside Betelgeuse, that distance would lie deep within the star's enormous atmosphere. The planet would not survive for even a moment. Its rocky surface would vaporize instantly inside the intense heat of the star. Next would come Venus. Venus orbits roughly 108 million kilometers from the Sun, yet even that distance would place it well inside Betelgeuse's swollen outer layers. The thick atmosphere of Venus would quickly evaporate. The planet itself would melt and dissolve into the star's massive envelope. Then comes Earth. Earth orbits the Sun at about 150 million kilometers. In our current solar system, that distance allows temperatures suitable for liquid water and life. But inside Betelgeuse, that orbit would be far from safe. Earth would lie deep within the star's extended atmosphere. The oceans would boil away instantly. The atmosphere would be stripped apart. The entire surface of the planet would melt into molten rock. Nothing on Earth could survive. But Betelgeuse's enormous size means the destruction would not stop there. The orbit of Mars lies about 228 million kilometers from the Sun. Even Mars would likely be swallowed by the star's outer atmosphere. The entire inner solar system would vanish inside Betelgeuse. Beyond Mars lies the asteroid belt, a region filled with rocky debris. Inside Betelgeuse, those asteroids would not remain intact. They would slowly vaporize and mix into the star's atmosphere. Only the outer planets might remain outside the star's physical radius. But even those worlds would face an environment completely different from anything we know. Consider Jupiter. Jupiter orbits about 778 million kilometers from the Sun. Depending on the exact size of Betelgeuse, the star's outer atmosphere might extend close to this distance. In some models, Jupiter could lie just beyond the star's edge. But even if Jupiter survived, the conditions would be extreme. Betelgeuse shines tens of thousands of times brighter than the Sun. The increased radiation would heat the outer solar system dramatically. Frozen worlds would warm. Ice-covered moons could melt. Even distant planets would experience a completely different environment. Meanwhile, powerful stellar winds from Betelgeuse would bombard the planets continuously. These winds carry huge amounts of gas and charged particles into space. Over time, they could strip atmospheres from nearby planets. They could reshape the entire structure of the solar system. But perhaps the most dramatic change would be the appearance of the sky. Imagine standing on Earth, somehow surviving just outside the edge of Betelgeuse's atmosphere. Instead of a small, bright sun in the sky, the horizon would be dominated by an enormous, glowing wall of red light. The star would fill a huge portion of the sky. Its surface would not appear smooth. Instead, massive convection cells would move slowly across its atmosphere. Gigantic plumes of glowing gas would rise and fall. The sky would glow deep red, reflecting the star's cooler surface temperature. And because Betelgeuse's atmosphere is extremely diffuse, the outer layers might appear almost transparent. You would see glowing currents of plasma drifting slowly across the sky. Massive arcs of stellar gas would stretch into space. Occasional eruptions might throw enormous plumes outward. But even this terrifying vision only hints at the true scale of Betelgeuse. Because despite its enormous size, Betelgeuse is still only one star among hundreds of billions in the Milky Way, and even larger stars exist elsewhere in the universe. Stars like UY Scuti can grow even larger than Betelgeuse. These cosmic giants reveal something astonishing about the universe. Stars can expand to sizes that swallow entire planetary systems. Yet despite their size, they remain temporary objects, because giants like Betelgeuse are nearing the end of their lives. Inside the core of the star, nuclear reactions are slowly reaching their limits. Gravity continues pulling inward. Radiation pushes outward, and eventually this delicate balance will collapse. When that happens, Betelgeuse will explode in one of the most spectacular cosmic events imaginable. But until that day arrives, the red giant continues shining quietly in the shoulder of Orion, a massive star glowing across hundreds of light-years of space, and a reminder that even the largest stars can one day vanish in cosmic fire. The day Betelgeuse explodes, for centuries, Betelgeuse has quietly burned in the shoulder of Orion, glowing with its deep red color. But unlike the Sun, Betelgeuse is not a stable, long-lived star. It is already near the end of its life. And when that life ends, the event will not be gentle. It will end in one of the most powerful explosions in the universe, a supernova. For massive stars like Betelgeuse, death begins in the core. Throughout most of its life, the star fused hydrogen into helium, producing enormous amounts of energy. That energy pushed outward, balancing the crushing force of gravity, trying to collapse the star. For millions of years, that balance kept the star stable. But massive stars burn fuel extremely quickly. The larger the star, the faster it consumes its energy. Betelgeuse, despite being only about 10 million years old, has already passed through most of its nuclear stages. After hydrogen fusion ended in its core, the star began fusing helium. Helium fusion produces heavier elements like carbon and oxygen. But that process cannot last forever. Eventually, helium also runs out. When that happens, gravity begins squeezing the core again. The pressure and temperature rise dramatically. Now the star begins fusing even heavier elements. Carbon becomes neon. Neon becomes oxygen. Oxygen becomes silicon. Each new stage happens faster than the last. Hydrogen burning lasted millions of years. Helium burning lasted hundreds of thousands. But silicon burning, the final stage, lasts only a few days. And then the core reaches a critical point. At the very center of Betelgeuse, nuclear fusion eventually creates iron. Iron is different from lighter elements. Fusing iron does not release energy. Instead, it consumes energy. That means the star can no longer support itself. Without energy pushing outward, gravity suddenly wins. The core begins collapsing. This collapse happens incredibly fast. Within less than a second, the core shrinks from the size of Earth to a sphere only about 20 kilometers wide. The collapse is so violent that atoms themselves are crushed. Electrons and protons combine into neutrons. The core becomes a dense object called a neutron star. But the collapse does not stop quietly. When the inner core suddenly halts, the outer layers of the star are still falling inward at tremendous speed. They slam into the newly formed neutron core. The energy released is unimaginable. In a fraction of a second, a shock wave forms. That shock wave blasts outward through the entire star. And when it reaches the surface, the star explodes. The result is a Type II supernova. For a brief moment, Betelgeuse will shine brighter than almost every star in the sky. Astronomers estimate the explosion could release as much energy as the Sun will produce over its entire 10 billion-year lifetime. All of that energy unleashed in just a few seconds. The explosion will blast enormous clouds of gas into space. These clouds will expand outward at thousands of kilometers per second. The outer layers of the star will scatter across the surrounding region of the Milky Way. But the explosion will not only release light, it will also release an enormous burst of neutrinos. Neutrinos are tiny particles that rarely interact with matter. Yet, during a supernova, trillions of them pass through every object nearby. If Betelgeuse explodes, neutrino detectors on Earth will detect the burst hours before the light of the explosion arrives. This early signal would alert astronomers that the explosion has begun. Telescopes around the world would immediately turn toward Orion. Space telescopes would focus their instruments on the dying star, and humanity would witness something incredibly rare, a supernova visible with the naked eye. But unlike a distant supernova seen in other galaxies, this one would occur only about 640 light-years away. That makes Betelgeuse one of the closest stars capable of producing such an explosion. Despite the incredible energy released, Earth would remain safe. The distance is far enough that the radiation would not harm life on our planet. Instead, the event would become one of the greatest astronomical observations in history. For weeks, the star would grow brighter and brighter. At its peak, Betelgeuse could shine as bright as the moon. It might even be visible during the daytime sky. At night, Orion would appear dramatically different. Instead of a faint red star marking the hunter's shoulder, there would be a brilliant white light dominating the constellation. Then slowly, over the following months, the brightness would begin to fade, but the expanding cloud of debris would remain visible for centuries. Astronomers call this expanding cloud a supernova remnant. Inside it, heavy elements formed during the explosion would drift into interstellar space. Elements like gold, uranium, and platinum. These elements did not exist before the star exploded. They were created during the supernova itself. Eventually, these materials will mix with gas clouds elsewhere in the galaxy. New stars and planets will form from those clouds, and the atoms created inside Betelgeuse may one day become part of new worlds, perhaps even new forms of life. This is the strange cycle of stellar death. When massive stars explode, they do not simply disappear. They transform the galaxy around them. They spread the ingredients needed to build planets, oceans, and living creatures. And in doing so, they reshape the universe itself. So, while Betelgeuse may appear peaceful tonight, glowing softly in the sky, its future is already written. One day, the red supergiant will vanish, and in its place, the sky will briefly hold one of the brightest explosions our species will ever see. What Earth will see. When Betelgeuse dies right now, Betelgeuse shines quietly in the shoulder of Orion. Most nights it appears as nothing more than a faint reddish star, visible to the naked eye from almost anywhere on Earth. But one day, that quiet star will transform into something extraordinary. When Betelgeuse finally explodes as a supernova, people on Earth will witness one of the most dramatic astronomical events in recorded history. And the transformation will happen faster than most people expect. The first sign of the explosion will not actually be light. It will be a burst of tiny particles called neutrinos. During a supernova, the collapsing core releases an enormous flood of these particles. They travel almost at the speed of light and rarely interact with matter. Trillions of them will pass straight through Earth and through our bodies without us noticing. But deep underground, massive neutrino detectors will detect them. Facilities like Supercamiocanda and Ice Cube Neutrino Observatory constantly watch for these rare signals. When Betelgeuse explodes, these observatories will detect the neutrino burst hours before the light of the explosion reaches us. Within minutes, alerts will spread across the global astronomical network. Scientists around the world will know instantly that something extraordinary has happened. Telescopes will swing toward Orion. Observatories on Earth and in space will prepare to capture every moment of the event. And then, finally, the light will arrive. The star will suddenly brighten. At first, the change may be subtle. Betelgeuse might appear slightly brighter than usual, noticeable only to astronomers who track its brightness carefully. But within hours, the star will grow dramatically brighter. Soon, it will outshine every other star in Orion, then every other star in the sky. Within a few days, Betelgeuse could become as bright as Venus, which is normally the brightest object in the night sky after the moon. But the brightness may not stop there. Some predictions suggest the supernova could rival the brightness of the moon itself. If that happens, the night sky will change dramatically. Orion will no longer appear as the familiar pattern of stars humans have recognized for thousands of years. Instead, a brilliant white star will dominate the hunter's shoulder. The constellation will look permanently altered, and, unlike normal stars, Betelgeuse will not twinkle. It will shine with a steady, powerful light. At its peak brightness, the star may even be visible during the daytime. Imagine looking up at the blue sky and seeing a bright star glowing faintly beside the sun. That is how powerful the explosion will be. But even though the explosion is enormous, Earth will remain safe. Betelgeuse lies about 640 light-years away. That distance protects our planet from the dangerous radiation produced by the explosion. If the star were much closer, perhaps within 50 light-years, the radiation could damage Earth's atmosphere. Fortunately, Betelgeuse is far enough away that the supernova will be a spectacular sight, not a disaster. In fact, astronomers will celebrate the event. A supernova this close has not been seen in centuries. The last comparable event visible to the naked eye was SN 1604, observed in the year 1604. Even earlier, ancient astronomers recorded the explosion of SN 1054. That explosion was so bright that it was visible during the daytime for weeks. the supernova of Betelgeuse could be just as dramatic. For several weeks, the star will shine intensely. Gradually, the brightness will begin to fade. But the explosion will not disappear immediately. Instead, expanding clouds of glowing gas will spread outward into space. These clouds form what astronomers call a supernova remnant. Inside, the expanding debris will be newly created elements. During the explosion, enormous temperatures and pressures allow the formation of heavy atoms. Gold, silver, uranium, and many other elements are created in this violent process. In fact, many of the heavy elements found on Earth today were created inside ancient supernova explosions. The iron in our blood, the calcium in our bones, even the gold in jewelry all originated inside dying stars. Betelgeuse's explosion will add new material to the surrounding region of the Milky Way. Over millions of years, those elements will mix with gas clouds. New stars and planets will eventually form from that material, perhaps even new life. From Earth, the glowing debris cloud will slowly expand. At first, it may appear as a bright point of light, but over time telescopes will reveal a growing nebula, a complex structure of glowing gas and dust. This nebula will continue expanding for centuries. Future generations of astronomers will study it to understand how massive stars die. The explosion will provide valuable information about stellar physics. It will reveal how shock waves travel through a star. It will show how elements are created during a supernova. And it will help scientists understand the life cycles of the most massive stars in the universe. But for most people on Earth, the experience will be far simpler. They will simply look up at the sky and see a star explode. For thousands of years, humans have watched the stars believing they are eternal, unchanging lights fixed in the heavens. But Betelgeuse will remind us that stars are not permanent. They are living objects, born, evolving, and eventually dying. And sometimes, when they die, they briefly become the brightest objects in the sky, a cosmic fire visible across the galaxy, a reminder that the universe is not quiet. It is constantly changing. And somewhere in the distant future, the familiar red star in Orion will vanish forever, leaving behind only a glowing cloud of cosmic debris, expanding slowly into the darkness of space. The monster that will remain. When Betelgeuse finally reaches the end of its life and explodes, the star itself will vanish. But something will remain. At the center of the explosion, buried beneath the expanding cloud of debris, a new object will be born. An object far smaller than Betelgeuse, yet far more extreme. To understand what will form after the explosion, we must return to the moment when the star's core collapses. Inside Betelgeuse, gravity is always pulling inward. For millions of years, nuclear fusion inside the star's core has pushed outward, balancing that force. But once iron forms in the core, fusion can no longer generate energy. The balance collapses. Gravity wins. The core implodes. Within a fraction of a second, the core shrinks dramatically. A region once the size of Earth collapses into something only about 20 kilometers across. The pressure becomes so intense that atoms themselves are crushed. Electrons and protons combine to form neutrons. The result is a new object called a neutron star. A neutron star is one of the densest objects in the universe. A teaspoon of neutron star material would weigh billions of tons. If such material existed on Earth, even a tiny fragment would crush through the entire planet under its own weight. Yet neutron stars are incredibly small. Despite containing more mass than the Sun, they are only about the size of a city. Imagine compressing the mass of our Sun into a sphere only 20 kilometers wide. That is the density of a neutron star. When Betelgeuse collapses, its core will most likely become one of these objects. But neutron stars are not quiet remnants. They are incredibly energetic. When the core collapses, the star's rotation speeds up dramatically. This happens because of the conservation of angular momentum, just like an ice skater spinning faster when pulling their arms inward. The collapsing core spins faster as it shrinks. Betelgeuse rotates slowly today, but the newborn neutron star may spin dozens or even hundreds of times per second. That means its entire surface could rotate hundreds of times every second. At the same time, the star's magnetic field becomes enormously powerful. Magnetic fields trapped inside the collapsing core become compressed and amplified. The result is a magnetic field trillions of times stronger than Earth's. Some neutron stars become objects known as pulsars. Pulsars emit beams of radiation from their magnetic poles. As the star spins, those beams sweep through space like the beams of a lighthouse. If one of those beams crosses Earth, astronomers detect a regular pulse of radio waves. Some pulsars rotate so quickly that they produce hundreds of pulses every second. These pulses are so regular that pulsars were once mistaken for signals from alien civilizations. Today, scientists use pulsars as extremely precise cosmic clocks. If Betelgeuse forms a pulsar, astronomers may detect its signal shortly after the explosion. But there is also another possibility. If the collapsing core becomes massive enough, it may not stop at a neutron star. Instead, gravity may continue crushing the core further. In that case, the core could collapse into a black hole. A black hole is an object so dense that not even light can escape its gravity. Once matter crosses a boundary called the event horizon, it can never return. If Betelgeuse forms a black hole, the object would likely be only a few tens of kilometers wide. Yet it would contain several times the mass of the Sun. From the outside, the black hole itself would be invisible, but astronomers might detect it by observing how nearby gas moves around it. Matter falling toward a black hole heats up dramatically. This gas can glow brightly in X-rays before disappearing into the event horizon. Either way, the remnant left behind by Betelgeuse will be extraordinary. But the star's death will also create something much larger. The expanding debris from the explosion will form a vast cloud of gas called a supernova remnant. These remnants can grow to enormous sizes. Over time, the expanding cloud will stretch across dozens of light years. Inside, the debris will be heavy elements created during the explosion. These elements are essential for building planets and life. Without supernova explosions, the universe would contain only simple elements like hydrogen and helium. Everything else, carbon, oxygen, iron, gold, was forged inside stars. When those stars explode, the elements are scattered into space. Eventually, they become part of new stars, new planets, and new living worlds. This is why astronomers often say that we are made of star dust. The atoms in our bodies were once part of ancient stars that exploded billions of years ago. Betelgeuse will continue that cosmic cycle. Its explosion will enrich the surrounding region of the Milky Way with fresh elements. Over millions of years, those materials will drift through interstellar space. Gas clouds will slowly gather them. Gravity will compress those clouds until new stars begin to form. Around those stars, new planetary systems will appear, and somewhere in those systems, new life might eventually arise. All of it built from atoms that once existed inside Betelgeuse. So, although the star's death will seem violent, it is also part of a larger story. Stars are not just sources of light. They are factories of matter. They build the elements that shape the universe, and when they die, they scatter those elements across the galaxy. Betelgeuse may one day disappear from the sky, but the material that formed the star will not vanish. It will continue traveling through space, joining new stars, new planets, and perhaps even new civilizations that will look up at their own skies and wonder where their atoms came from. The shockwave that will reshape space. Long after Betelgeuse explodes, the story of the star will not end. In fact, the most dramatic transformation will only be beginning. Because the explosion will launch an enormous shockwave into space. This shockwave will travel outward at thousands of kilometers per second, sweeping through the surrounding region of the Milky Way. For centuries, astronomers have studied the remnants of ancient stellar explosions. These expanding clouds of gas reveal what happens after a massive star dies, and Betelgeuse will eventually create a similar structure, a vast, glowing nebula, slowly expanding into the darkness of space. The explosion itself will throw the star's outer layers outward in every direction. These layers contain enormous amounts of gas that Betelgeuse has been shedding throughout its life. Red supergiants are unstable stars. Even before the final explosion, they lose mass through powerful stellar winds. Over thousands of years, Betelgeuse has already filled the space around it with clouds of gas and dust. When the supernova occurs, the expanding shockwave will collide with this material. This collision will produce spectacular structures. The shockwave will compress the surrounding gas, heating it to millions of degrees. As the gas heats up, it will begin to glow. Different elements will emit different colors of light. Hydrogen will glow red. Oxygen will produce green and blue tones. Sulfur will appear yellow. Through powerful telescopes, astronomers will see enormous filaments and glowing arcs spreading outward from the explosion. These structures are often incredibly complex. Turbulence inside the expanding gas creates twisting shapes that stretch across space like cosmic clouds. One famous example of such a structure is the Crab Nebula, created by the explosion recorded by astronomers in the year 1054. The Crab Nebula continues expanding today, almost 1,000 years after the explosion that formed it. Betelgeuse will eventually produce its own remnant, one that future civilizations may observe for thousands of years. At first, the expanding cloud will be extremely bright. The energy released during the explosion will heat the gas intensely, but over time, the gas will cool and fade. Yet, even as the brightness fades, the remnant will continue expanding. The expanding shell may grow to tens of light years across. Inside the cloud, heavy elements created during the explosion will mix with the surrounding gas. These elements include carbon, oxygen, silicon, and iron, the building blocks of planets and life. Before stars like Betelgeuse formed, the universe contained almost none of these elements. After the Big Bang, the cosmos consisted mostly of hydrogen and helium. Everything else had to be created later inside stars. Massive stars like Betelgeuse are especially important because they can forge many heavy elements deep inside their cores. But the most extreme elements are created only during the moment of explosion. During the supernova, temperatures briefly rise to billions of degrees. Under these conditions, atomic nuclei collide violently and combine into heavier atoms. Gold, platinum, uranium, and many other rare elements are produced in this process. Once formed, these elements are blasted into space along with the rest of the exploding star. Over millions of years, they will drift through the galaxy. Eventually, they may become part of new planetary systems. In fact, scientists believe our own solar system formed from gas enriched by earlier supernova explosions, the iron in Earth's core, the oxygen we breathe, the calcium in our bones. All of it was created inside ancient stars. When Betelgeuse explodes, it will contribute to this ongoing cycle of cosmic recycling. But the explosion will not only scatter material, it will also shape the structure of the surrounding region of space. The expanding shock wave will compress nearby clouds of gas. When gas clouds become compressed, gravity can cause them to collapse. And when a gas cloud collapses, new stars begin to form. In this way, the death of one star can trigger the birth of many others. Astronomers have observed regions where supernova shockwaves appear to have triggered entire clusters of new stars. These newborn stars may form only a few million years after the explosion that created the shockwave. If Betelgeuse explodes near a dense cloud of interstellar gas, the shockwave could initiate similar star formation. New stars may appear in the region surrounding the explosion. Those stars will contain atoms forged inside Betelgeuse itself. This process demonstrates something remarkable about the universe. Stars are not isolated objects. They influence the birth and evolution of other stars across vast distances. The death of Betelgeuse will therefore become part of a much larger cosmic chain reaction, a chain that stretches across millions of years. Even after the remnant fades from view, the consequences of the explosion will remain. The elements scattered across space will become part of new cosmic structures. New planets may form from that material. Some of those planets may eventually develop oceans and atmospheres. And somewhere in the distant future, living organisms might arise on those worlds. Those organisms will contain atoms forged during the final moments of Betelgeuse's life. Atoms created during one of the most powerful explosions in the universe. And in that way, even long after the star itself has vanished, Betelgeuse will continue shaping the cosmos. A silent reminder that the life cycles of stars are deeply connected to the creation of everything around us, from galaxies and planets to life itself. Why Betelgeuse is already changing. For most of human history, Betelgeuse has appeared almost unchanged in the night sky. It shines as one of the brightest stars in Orion, glowing with a deep reddish color that easily catches the eye. But modern astronomy has revealed something fascinating. Betelgeuse is not stable. In fact, the star is constantly changing. Unlike the sun, which shines with a relatively steady brightness, Betelgeuse is a variable star. Its brightness rises and falls over time. Sometimes it becomes brighter. Sometimes it fades dramatically. Astronomers have been tracking these changes for more than a century. Two main cycles of variability dominate the star's behavior. One cycle lasts about 400 days, while another, longer cycle lasts around 2,000 days. These changes occur because Betelgeuse is not a calm, stable sphere. Instead, it is an enormous, turbulent star. Inside Betelgeuse, vast currents of hot gas constantly move upward from the interior. When this gas reaches the surface, it cools and sinks again. This process is called convection. On the Sun, convection produces relatively small features known as granules. But Betelgeuse is so large that its convection cells are enormous. Some of them are believed to be as large as the entire orbit of Earth. These giant bubbles of gas rise and fall slowly across the star's surface. As they move, they change the brightness and shape of the star. Powerful telescopes have even been able to image Betelgeuse directly. Unlike most stars, which appear only as points of light, Betelgeuse is large enough and close enough that astronomers can resolve its surface. Using instruments like the Hubble Space Telescope, scientists have observed bright and dark patches moving across the star's face. These patches correspond to massive convection cells, but convection is not the only reason Betelgeuse changes. The star also pulsates. As the outer layers expand and contract, the star grows slightly larger and smaller over time. During expansion, the star cools slightly and becomes dimmer. During contraction, the surface heats up and the brightness increases again. These pulsations contribute to the regular cycles seen in the star's brightness. However, in recent years, something far more dramatic happened. In late 2019 and early 2020, Betelgeuse suddenly faded to an unusually low brightness. The event surprised astronomers around the world. For a short time, Betelgeuse became less than half as bright as normal. Some scientists began wondering whether the long-expected supernova might be about to happen. The dimming became known as the Great Dimming of Betelgeuse. Telescopes across the planet focused on the star to understand what was happening. New observations soon revealed the cause. Betelgeuse had ejected a massive cloud of gas from its surface. This gas cooled as it moved away from the star. Eventually, it condensed into tiny dust particles. When that dust cloud passed between Betelgeuse and Earth, it blocked part of the star's light. The result was a dramatic drop in brightness visible from Earth. The discovery was made using several powerful observatories, including the Hubble Space Telescope and the Very Large Telescope. Together, these instruments revealed that Betelgeuse is actively losing material into space. In fact, the star sheds enormous amounts of mass every year. Some estimates suggest Betelgeuse may lose as much mass as Earth every few years. This mass loss occurs through powerful stellar winds and violent eruptions from the star's surface. Over time, this process will gradually strip away the star's outer layers. The surrounding region of space is already filled with material expelled by Betelgeuse during its lifetime. Astronomers have detected enormous shells of gas surrounding the star. These shells represent previous episodes of mass loss. When Betelgeuse eventually explodes as a supernova, the shock wave will collide with these shells. That interaction will produce spectacular structures in the expanding supernova remnant. But the Great Dimming also taught scientists something important. Betelgeuse is extremely dynamic. It is not quietly waiting for its final explosion. Instead, it is constantly changing. Gigantic plumes of gas erupt from its surface. Massive convection cells churn deep inside the star. The entire star slowly expands and contracts. In many ways, Betelgeuse resembles a boiling pot of cosmic plasma. Its surface is unstable and constantly shifting. Yet despite all this activity, astronomers believe the star is probably not about to explode immediately. The final supernova could still occur tens of thousands of years in the future. Or it might happen tomorrow. At stellar timescales, both possibilities are essentially the same. But the changes we observe today allow scientists to study the late stages of massive stars. Betelgeuse provides a rare opportunity to observe the behavior of a red supergiant nearing the end of its life. Few stars are both large enough and close enough for such detailed study. And that makes Betelgeuse one of the most important stars in modern astronomy. Every eruption, every dimming event, and every pulse of brightness reveals something new about how massive stars evolve. Each observation brings scientists one step closer to understanding what will happen when the star finally collapses. One day, Betelgeuse will disappear from the sky, but until that moment arrives, it continues to offer a front-row seat to the dramatic final stages of stellar evolution. A giant star slowly approaching its ultimate transformation. The night the sky changes forever. For thousands of years, humans have looked up at Betelgeuse and seen the same familiar sight. A dim red star glowing quietly in the shoulder of Orion. Ancient civilizations watched it rise in winter skies. Navigators used it as a reference among the stars. Stories and myths were built around the shape of Orion, the great hunter. To most people, the stars appear permanent, unchanging lights fixed forever in the heavens. But Betelgeuse reminds us that the universe is not static. Stars are born, stars evolve, and eventually, stars die. When Betelgeuse finally reaches that final moment, the sky itself will change. The explosion will begin deep inside the star's core. Gravity will crush the collapsing core until it forms an incredibly dense object, likely a neutron star. The sudden halt of the collapse will launch an enormous shockwave outward through the star. Within seconds, the entire outer envelope of the star will be blasted into space. At that moment, the star that has existed for millions of years will vanish. In its place will appear one of the brightest explosions in the Milky Way. From Earth, the transformation will be astonishing. At first, Betelgeuse will brighten rapidly. Over the course of days, it will grow brighter than every star in the night sky. Soon, it could rival the brilliance of Venus. Then possibly even approach the brightness of the moon. Imagine looking up at the winter sky and seeing Orion with a brilliant new light shining from its shoulder. A light so bright that it casts faint shadows at night, a star visible even in daylight. People everywhere on Earth would notice it. Astronomers would immediately begin observing the explosion with every telescope available. Space telescopes would capture images across many wavelengths of light. Radio telescopes would track the expanding debris cloud. X-ray observatories would watch the newborn stellar remnant. For scientists, it would be a once-in-a-lifetime opportunity. A nearby supernova provides a perfect laboratory for studying the final moments of massive stars. For weeks, Betelgeuse will shine intensely. Then slowly, the brightness will begin to fade. The brilliant point of light will gradually dim. But the story will not end there. The explosion will leave behind a vast cloud of glowing gas expanding outward into space. Over decades and centuries, this cloud will grow larger. Telescopes will reveal intricate filaments and arcs of glowing material. Inside the cloud, new elements forged during the explosion will spread through the surrounding region of the galaxy. Elements that will eventually become part of future stars and planets. The explosion will mark the end of Betelgeuse as a star, but it will also mark the beginning of something new, because the matter scattered across space will not disappear. It will become part of the ongoing cosmic cycle. Stars are not isolated objects. They are connected to everything around them. The life of a star influences the birth of other stars. The death of a star spreads the ingredients for planets and life. Without supernova explosions like the one Betelgeuse will produce, the universe would be a very different place. There would be no heavy elements, no rocky planets, no oceans, no living creatures. Every atom heavier than hydrogen and helium was created inside stars, and many of the heaviest elements were formed during the violent death of massive stars. That means the atoms inside our bodies were once part of ancient stars that exploded billions of years ago. We are literally made of stellar debris. When Betelgeuse explodes, it will continue that cosmic process. The star's material will drift through space for millions of years. Eventually, that material may help form new solar systems somewhere in the Milky Way. Perhaps even new planets with oceans and atmospheres. And somewhere in the distant future, life might evolve on those worlds. Life built from atoms that once belonged to Betelgeuse. So when we look up at the red star today, we are not just looking at a distant object. We are looking at a star nearing the end of its cosmic story. A story that began millions of years ago, when a massive cloud of gas collapsed under gravity. A story that will eventually end in a brilliant explosion, lighting up the sky. But the true ending of that story will stretch far beyond the explosion itself. Because Betelgeuse will not simply disappear, its atoms will continue traveling through space, joining new stars, new planets, and perhaps new civilizations that will one day look up at their own skies and wonder where their atoms came from. The red star in Orion will fade, but the legacy of Betelgeuse will echo across the galaxy for millions of years. A reminder that in the universe, even endings are beginnings.